My name is Vladimir Vivien. I am a software engineer, and in my day job, my weekend job, and night job, I write Go. Um, and this is the second time I'm doing this presentation. The first time I did it for the Tampa Java user group. And the reason why I did it is because I used to do Java for a long time. And for the last 10 to 12 years, or it might be 10 years, I don't remember exactly, I've been doing Go. So today we're gonna go over Go and take a look at the programming language from the perspective of somebody who's been doing Java and might be interested in learning more about Go. So let's get started. So this is about me. As I said, I'm a software engineer. In 2016, I wrote a book called Learning Go Programming. And last year, I put out a LinkedIn course called Programming with Go Modules. And yeah, so if you're interested, check those out. So this is the agenda for today. We're going to take a quick look of what Go is, and then going to talk about again starting Go. And then, as I was explaining before we got started, the way this is going to go is going to look at high level or high level features and topics about Go and how it relates to the same features and topics in Java, so that if you're already a Java developer, that will help you see how it is done in Go and possibly help you learn or pique your interest. And then later on, we'll go over more code examples if we have time, and question and answers at the end. Any questions? All right. So what is Go? Well, my definition is Go is a modern general purpose programming language created to solve large scale software engineering problems at Google. And I said at Google because the language was created at Google. Um, Go, and I deliberately put software engineering problem at large scale because Go is not just a programming language and compilers and stuff like that. It is a full suite software engineering. It comes with a full suite of software engineering tools to help you not just write code, but solve problems that once you write your code that you may run into. Such as packaging, such as making sure your code is secure, supply chain issues that may rise. Go has tools for all of that. We won't be looking at any of that today, but I just wanted to point that out. So Go by the numbers. Go goes between, but it's usually in the top 5 of most love languages. It goes back and forth, but it's usually in the top 5 or somewhere in within top 10. Um, Very high level of developer satisfaction, and depending on which research or publication you're looking at, it goes between 2 million active developers. But there's a lot more folks who have used Go that are writing code with Go. So in the wild, you may be wondering who's using Go, and the answer is pretty much everyone who's building a large scale system where performance is needed. So this screen shot I pulled maybe a couple days ago from go.dev, and we'll go over what go.dev is. And it's just a list of companies that are currently or have stories about how they use Go, and of course Google being one of the first ones. Tools that you may know that are written in Go. So if you've used Docker, Kubernetes, Podman, which is an OCI or a container manager. K3S, which is a simplified Kubernetes, Container D. Any one of those tools, you're basically using something that was written in Go. And this is not by accident. It's because when Go came out right around 2009, that's when Kubernetes wasn't too far behind. And the folks who at Google, when they were creating Kubernetes, they pivot and selected Go. And so in Go, you will find that it is very well suited for cloud native development. And it's kind of a interesting cycle. So Kubernetes is written in Go, and Go is also very well suited for the stuff that Kubernetes allow you to do, which is cloud-based computing, cloud native computing. Any DevOps infrastructures such as Terraform, Packer, Helm, they're all written in Go. Um, um, we got networking tools like Cilium, Tailscale, which was very interesting. I didn't even realize Tailscale was open source until I started searching, but it's written in Go. There's another VPN called Nebula that's written in Go. Istio, Trafic. And the list goes on. For instance, monitoring and observability, Prometheus, Grafana, Jaeger, the Open Telemetry Stack, Victoria Metrics, etc. etcd, which for storage and databases, etcd is a key component inside Kubernetes. It's a uh, key value, a storage system that is used inside Kubernetes. It's written in Go, InfluxDB, CockroachDB, MinIO, NATS, and the list goes on. This is just to give you an idea of some of the tools that you may use or may have heard that are written in Go. All right, any questions? All right, cool. Let's see. So that's all good and dandy, but if I was to be, if I selected Go, what sort of application I'm most likely would be writing? Usually, a lot of folks use Go for command line tools. Great set of features and packages are available for you to write very attractive, well designed CLI tools. I already mentioned cloud native applications. Because Go, when you compile it, it creates a single static binary. It makes it ideal to deploy application for cloud native applications because you have fast startup, low memory, low memory. Can I, if you are not, yes, thank you. Yep, sorry. And then distributed architecture. Go is also, because it has libraries that makes it easy to build connected distributed programs. It's a great choice to write those type of application. Service API. Go supports both REST and binary-based RPCs, such as gRPC, and your services out of the box is capable of handling thousands of connections. Cross-platform. Go is cross-platform in that it allows you to build for different architecture where Go is supported. What I mean by that is where Go has tool chains for that particular um, um, target platform. And obviously high performance is where Go shines. We'll see a lot of that too as we continue the presentation. Is Go is well suited for writing high performance application because it has built-in concurrency and constructs for IO to build IO sensitive applications. And we'll go over all that, or at least we'll see some example of these features. All right, so if you said, hey, I want to get started with Go, how easy or hard it is to get started? Well, the first place you would want to go is go.dev. Very simple, very easy. And Go.dev is a landing page from Google for the Go toolchain, where you can download it, get documentations, um, and read about how other people are using Go, use cases, et cetera, et cetera. Um, Editors and IDEs. I mean, the top ones that usually you find people using is Visual Studio Code or JetBrains Golang. I didn't put. I should have put Vim on there. Go is also well supported if you use Vim. Um, the the playground, I put it on the slide because it is a web-based, and we'll see it in during demo. It is a web-based. Basically, it's a web page with an editor where you can put Go code in there and run it right then and there, and that is a testament to one of the important tenets of Go, which is not just Go being performant at runtime when you build and run your application, but the folks who are responsible for Go, they're very obsessed about build time performance. So because of that, you can build your Go code and have a quick um, build cycle that makes it look like it's a dynamic language when in fact it's not. So when you run the code in the browser, what's actually happening is it's running it in a container somewhere in the cloud, and you get the result within seconds. So at this point, we're going to do the Go side by side, as I've mentioned. But before I go on, any questions from you guys? All right. Um, so what I wanted to do is, as I explained earlier, is um, rather than just going over Go and diving into the minutia of Go, I wanted to pick several topics or features that I think would be of interest to Java developers and see how they're done in both languages to kind of give you an idea how Go works, and so you can see with your knowledge of Java how to help you understand how these features work. Okay, so the first thing, a high level side by side of the two technologies and how different features are implemented. So the first thing is both languages are static type system. They're both strict type, meaning that all your variables or your data have to have a type. Go does support implicit typing. We'll see that when we look at some code in a few minutes. And what that means is the compiler will infer a type just based on the value being assigned to a variable. Both languages are garbage collected. Um, Whereas Java gives you a bunch of knobs for you to tweak and fine tune the garbage collector. Go takes a minimal approach where you get almost no knob for you to tweak. But what they've done, in fact, is make sure that you get a performant garbage collector that gives you milliseconds, almost sub millisecond. Well, it's not sub, but it's millisecond GC pauses, and also at compile time, the compiler will do some optimization for you, so that you don't need to have control knobs to make sure that you get the most out of your garbage collection. Both languages are cross-platform, but they do it very differently. Java is cross-platform, where you write the code once, and once you write it, the bytecode is executable on any platform that the JVM it can run. Where Go, on the other hand, you write the code once, but you can compile to target a platform that is supported by the Go toolchain. And the next one is, compile time. What do you get? Well, Go, when you compile your code with Go, you get a single binary, and that's it. It's a static binary. 99% of the time, it's a static binary. There are circumstances where you may have dependencies on some sort of object file of some sort. But 99% of the time, you're not doing any kind of binding to any C libraries that may need to be brought over for your code to work. In Java, what you have is as I mentioned before, when you compile your code, you get a bytecode, and that bytecode is what you take around and you let the JVM run it for you. As far as concurrency, Go uses what are called Go routines. They're a lightweight thread of executions. And that is the unit of concurrency that Go uses. And we'll see in examples how you can use channels and other synchronization primitives to synchronize Go routines. Java uses OS threads, which are a little bit heavier, but you get full control over when the thread starts, when it stops, and you have to also do the coordination between, especially you have multiple threads, you have to handle the coordination yourself. The Go routine, on the other hand, they're not real threads. They're, I think, if I remember correctly, I think there's an effort to bring lightweight thread in Java as well. I think it's called green threads. So it's something like that. They're not OS threads, but they're managed by the Go runtime, and they're scheduled. They're garbage collected and cleaned up automatically for you. So that allows you to scale at in the thousands of Go routines in your program, and you get that for what seems like it's for free. Obviously, you have to be careful not to do something that'll cause you to crash. But as far as managing the Go routine, the runtime takes care of that for you. Object-oriented without classes. So Go does not have the notion of class. You can create objects. Again, we'll see that a little bit later. You can create objects, but they're not your typical class as we have in Java. Java is a classical OOP in that it's all class based, and it supports inheritance and stuff like that. Whereas the Go object orientation, the most you'll get out of it is composition with embedding different objects within the other. Error handling. Now, if I'm not going to go too deep into it because we're going to look at some of the stuff in a little bit later, but Go has what we call explicit error handling. That means when you call a function or a method, you are responsible for checking if that function or method resulted in an error. Whereas Go has the exception mechanism that makes things a little bit more optional, because if you don't catch that error, if you don't catch an exception, I should say, eventually it'll bubble up all the way to the stack, causing you to have a runtime exception stack dump on your screen. But in Go, because errors are values just like any other value, you have to, when the function or method you call returns an error, you have to crack it open to see if there was in fact an actual error. Otherwise, it may go silent and you would be in a world of hurt. But again, we're gonna see more of that in a few minutes. Um, One thing I wanted to point out is source-based packages versus binary-based packaging. Go uses source-based packaging, so for package reuse and in your code. Um, so when I pull a package in my Go source code at build time, or while I'm writing my code, I'm actually pulling down a copy of the source code from a repository somewhere. Whereas Java uses a binary-based package system where when you pull down a package, you're actually pulling down a jar of some sort that has the bytecode that you will need. Um, there are advantages and disadvantages in both. One advantage in the source base is that, you know, one of the things you can guarantee is that you can repeat, and repeatability is a big theme in Go packaging system where, you know, if you're pulling the same, when you pull the same version of the source code, you should be able to reproduce the code at any time. So that's one of the big advantages of having source-based packaging. Any questions? All right.
Comment.
Yes.
Virtual threads. That's the new one. That's what it's
Mhm.
called. So green threads are the in the original one, Java 1, where um
Oh, that's right.
that's the original one. So that was because there wasn't POSIX threads at that point. Because
Right.
right. So they got rid of that, and then the new one is called virtual threads, and
Virtual
it's
threads. Okay.
yep.
Is that implemented yet, or is that still
Yes,
coming?
yes, it's production.
Oh, okay.
Uh, yeah, Tomcat, all these things that are out there taking full advantage of that, increasing performance with the virtual threads.
That's awesome. Yeah, that's awesome. Um, and is it the same thing where the runtime basically schedule well, they're not true thread, are they? I mean, they're virtual thread in that they're being managed
They're being
by.
managed as one to many, so like or should I say many to one actually.
Mhm.
And so there's an actual operating system thread behind the scenes, but they're sharing it, and
Okay, good.
especially when
Same
there's
idea.
yeah, when they're
Okay, same
paused,
idea.
so they can get the increased performance.
That's awesome. Um, cool. All right. Well, that's one slide I will be updating. Thanks for pointing that out. All right. Another thing the first thing or another side by side we'll do is to look at the source code um, of both Go and Java. So the first thing you do when you write your Go code, is similar to Java, is to declare what package that the source code is part of. So you do that with a package keyword, similar to how you do it in Java. The difference is in Go, the package name is not tied to the directory structure under where the source code lives. So you can give your package whatever name you want, and the tooling will figure out where it is with respect to other packages. Whereas in Java, you use that reverse DNS naming scheme where each segment in the name is a directory, is a directory where the code lives. The next thing is um, the dependencies, and as you can see in Go, because there's no direct relationship between the name of the package and the way and where it's saved. The names tend to be a little shorter. Um, and then the rest of the source code is where you keep where you the body of the code, right? Excuse me. If you look at the Java source, the Go source code, you'll see that it is not wrapped in any other structure. You can start typing right away, or start, declaring your types and your values right away, your functions, etc. Whereas in Java, everything must be wrapped in a class, unless that has changed since I've used Java. But I believe that it's still it's still the case. All right. So I've been talking for about 20 minutes now. So let me go and let's look at some Go, and then we'll be back to continue. All right. So can you see my screen? Yes. Okay. Awesome. All right. So this is a very simple program that's my version of Hello World. Um, let's look at let's explore what makes a package. So here you have what they call the Go module files. These files get filled up as you add dependency to your code. I don't have a lot of dependency here. That's why it's pretty much empty. But as you add dependency to your code, you're pulling other packages from other libraries, etc. The Go tool will automatically fill in your module dependencies for you, or at least you don't have to fill it in manually. You can use the Go tools to fill that in for you. The This package or this source code is using a synthetic name, but it's a special synthetic name called main. And that name is reserved for any packages that will be compiled to be an executable. So you cannot have, more than one main in one package. So that's the only package that you can only have one main per package, and you can also have one main function in a package that has main, because that is the entry point for your program. So any package that is named main has a main function that is considered an executable package, meaning that I can compile this as a program. So let's go ahead and do that. And if you have any questions, let me know. Okay. Oh, can you guys see this? Okay. I don't need
Yeah,
to.
yeah.
Okay. All right. I don't need to enlarge it or anything. All right.
I enlarge it by getting closer to the screen. Does that work?
I'll bump it up one more. All right. So let's go into this is two.
Oh, Vladimir, I have a
Yes.
question.
Yes.
Yes. So how many main functions can you have in the project? Is it only one? I think I missed it.
No, you can have different. The main function is a reserved function name, and it has to be part of a package name main. The I'm trying to think, can you just have a main? I've never done it where you put a main name, but it's not part of a main package. I don't know if you can or not. I'm pretty sure you can. But if you have a package that you know that you want to compile to be an executable, you would put it in a main package, which I'm about to show you. And then when you do that, you also got to provide a main function, which is the entry point for your executable. So couple things I want to show you. So this is go run, and it takes the current directory. So it's going to look for any source code that has the main, compile it, and run it all in one command. So what it just did is it's kind of cheating because I've compiled it before, it cached it. So when I do it again, it compiled it, and matter of fact, let's do this. I think this will work. X, I think. All right, so it shows you that it compiled it. No, actually, it's cached. Yeah, and then because it's cached, it didn't compile it. It just ran it. It just ran it. So that's that. But if I want to end up with that single binary I keep talking about, I could do a go build dot. I could do a dot, and it did not. It looked like it did nothing, but it did a lot. It actually. Let me do this. I don't like the name. It's defaulting it. It's defaulting to the parent name of the directory. So let me do this. I'm gonna remove it. Go build out. Hello. Did I do it? Yes. So if we look here, we see that it created the binary. It's about what? About 2 meg. But that 2 meg has everything I need. It's a complete program, basically. That's what I'm trying to say. It's a complete program. You don't need anything else. I can take that file, that binary, give it to you. It'll run. I can wrap that binary, as in a container. It's ready to run. There's no outside dependencies for it to run. So what that allows you to do, and that's one of the things that really one of the reasons why people gravitated toward Go early, especially in the cloud native, is that now you have you have something that can give you a single binary that you can take and wrap in containers, and deploy anywhere really where that binary format is supported, and it'll run. So let's do this, and that's it. So that is a Go binary that was just compiled. Any questions?
Yes, I have a question, Vladimir.
Yes.
What happens if you change the age and just run it? Will it identify the change and recompile it, or
No, you still have to do now they do have they have tools out there that'll do a hot reload type. I think that's what you're asking. But if you just using Go, if I change this, welcome to Go. Okay, if I change that, I could do this. It just that did that command compiled it and ran it for me. Just that quick. So because of that, folks have done there are tools out there that'll sit there and watch your changes and recompile depending on what you're doing. But it happens so fast, I tend not to need it. It also depends on what kind of development you're doing. For what I usually do, I don't have the need to have hot reload. But if you're doing something that's web based, you may want to have that. And some tools do have hot reload. Which brings me to another point. Let's see. Go play. Yeah, there you go. I wanted to show you the playground. So this is what I was talking about. This is the Go playground, and it's using the latest version of Go. And this is it's not a full IDE, but it's an editor that gives you access to writing code and have it compiled on somebody else's machine. So if I go ahead and I just press, I don't know if you saw it, but I pressed run, and it compiled it and ran it and showed me the output. And you can, I use that actually. I use that quite a bit. If I'm thinking of something or I'm doing research on something, I'll come here and open it up, type something, run it, play with some ideas, just because I don't want to set up a new project or anything like that. and you can't beat the instant gratification that you get from this. All right. So going back to my IDE, one thing I will point out, this is Visual VS Code, but I'm running it as GitHub code space. So I have a GitHub repo with a bunch of code examples that I use to talk about Go. So I just start that as in code space, and that's what we're looking at. But day to day, I also use VS Code as well. All right, I wanted to show, yes. So this source right here is a library. And I wanted to show, because I talked about what, executable. So I wanted to show what a library looked like. So this is, you see how I have the package name being lib, and it is recommended that the package name matches the directory where the files lived, so that you're not causing confusion. You don't have to, but it makes sense for you to do so. This package, I should say, does not have a main. And then we're gonna see where I think I use it here. So now this is where I'm importing that library, or that package, I should say, so that I can use it. So you see that it's pointing to lib. So somewhere down here, I'm importing lib here, and I'm using it here, just so to give you an idea of what a library looks like in Go.
Vladimir,
Okay.
can you show us the please excuse me, the other file, the one that you're importing from, because I didn't see
Oh,
it has
yeah,
your
sure,
name
sure.
on it.
This?
Yeah, why did you have to put your name on it?
Okay, so very good question. That's an awesome question. If no one asked, I wasn't going to bring it up. But since you brought it up, since you asked, I'm
Sorry,
going to bring
Vlad.
it up. So when you start a Go project, one of the first thing you have to do is to set up a module. You have to, it's called, you have to set it up as a Go module. And you do that with a command called go mod. And one of the things you give it is an identifier for your module. That's what that is.
Right.
Excuse me. It's an identifier for my module. And any packages in my module will have that identifier prefixed in it. Now, so actually, let me keep going. So because this package lib is part of this module, which is called this Vladimir/time. So I have to put that in there to basically identify which module I'm talking about and which package in the module I'm talking about. So this is the module prefix, and this is the actual package in the module. Now,
So from now on, Vladimir, we all have to use your name.
Oh, absolutely. Absolutely.
Okay, perfect. Okay, I can do that.
And there's more implication in this that we probably won't see, but what this is also used is I can use that prefix as 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 um as a name to point to a location, a remote location where my modules are. So what does that mean? What that means is, I'm going to change this real quick. I'm going to do it by hand though. So I could have done this, github.com, and I think was it time? Okay. So this is a valid module prefix, but it's also happened to be a GitHub path to a repository that is part of my GitHub. I mean, this is an example. I don't really have that in GitHub. So what the tooling will do too is, if it sees that your module prefix is a path for GitHub, and there's like 5 of them that it supports, it'll attempt to pull that code from the remote repository. Does that
Very
make
nice.
sense?
It
Yes.
does. That's very
Yes.
nice.
So it automatically will be like, oh, okay, I see that this module is live in GitHub or GitLab, or there's like 5 or 3 or 4 other source code manager that it supports, and it automatically try to resolve your module as that GitHub path indicates. And you can see them here. So this particular module is using other modules, and you could see that these modules have GitHub-based prefixes, import paths, so that the tooling will automatically go to this location and pull the package that's there with the version, etc. There's a whole matter of fact, I just thought about it. The in the beginning, I mentioned that I did a LinkedIn class, and that entire class, or LinkedIn, uh, it's a
Module?
yeah,
LinkedIn
the LinkedIn module. Yeah,
Okay.
I know.
That's
It's
fine.
all about using, understanding Go modules. So
Nice.
it's a very deep topic, and it has a lot of implications, but it works really well. As far as dependency management, and Go, that works really, really well. All right.
Thank you.
Time is moving on. Let me go back to the presentation. We'll come back to more code in a minute. So let's look at some more side by side. Okay. Actually, we'd looked at that already. All right. All right. So we looked at code, so we know that both Go and Java have basic types. So what I wanted to point out though is that that's what I meant by Go has implicit type, where here, let me change this to laser point. Yeah, there you go. So Go has implicit type, where name will be of type string, but notice that we didn't tell the compiler that it is string. It's going to infer that from the value that is being assigned to the variable. And this is what's going on here. But you can also do explicit type assignment, like for instance, var counter is an integer, and you can also do assignment right there, right when you do the declaration, which is what we're doing here. So let me keep going. And then you have stuff like composite types in both languages. Go has arrays, which are static fixed sizes, as shown here. But Go also has the notion of slices, which are dynamic. That can be, it grows inside and shrink. Maps is also a built-in type. and structs, which we saw earlier as a built-in type. The Go type system is not very, but it's small. Besides number, string, Boolean, and those composite types, there's not a lot of other types. I might have missed a few, but that's it. The type system is very minimalistic. And this on the Java side kind of gives you a comparable side by side, so you can see what the what types maps to what. For instance, uh, you know, in Java you would use a class to create an object. In Go, you would use the struct to create an object, and we'll see a better example later on. Um, Here we go, objects. So as I had mentioned, you use struct to create object, and the struct is just a collection of named field, type name field. So we have bank account. We can optionally have a constructor function, but you don't have to. This is just a nice to have to kind of help build, create an initial value of your object. And then in Go, you can attach methods for behavior to your type. So this is what's going on here. We are attaching this method deposit to an instance BA of this type. And the thing I want to point out is you can actually in Go, you can attach behavior to just about any types. Struct being one of them. You can attach methods to a string type, any type that you declare. So having somewhere to have state and behavior gives you an object in Go, and you do that with a struct. And here on this side, we see the equivalent of bank account being implemented in Java. So this would be doing the same thing, but as you can see, it's done very slightly different. Any question? All right. So concurrency. I think I had already mentioned that Go supports something called Go routine, which are lightweight thread execution of thread executions. The way that you initiate that is using the Go keyword followed by a function. In this case, we're using a function literal, but we can put a name function there. But basically what this is doing is scheduling this block of code to get executed on a thread somewhere that is managed by the Go runtime. And this can scale in the thousands. I can, keep creating these, and the runtime will take care of set them up, run them, and shut them down and clean them for me. And this is one of the, I think this is, for me, one of the most powerful feature of Go is, the simplicity of launching executable code blocks on their own thread of execution. So in this particular example, what we're doing is we're launching two Go routines. This is one, this is two, and we're using something called a wait group to coordinate. And what that does is we'll come down here. So this will get launched and immediately return. This will get launched and immediately return. Now, you have no guarantee of order of execution. So this might execute first, but it might not. This block might execute first, but it might not. And then as they get executed, we can come here and wait for both to get done using this mechanism called a wait group. And the way it works is when we're done, we call defer, and we'll talk about defer in a few minutes, to indicate that that wait group is done, that instance of the wait group is done. So basically it's a countdown latch. So we set it at 2. Whenever we call done, it decrements to 1. When we call done here, it decrements to 0, and then it's done waiting and it moves on. So this is something similar, that kind of gives you an idea what's going on. Here, we're using a lambda function to pass in the runnable that gets that the thread will run. And we kind of do something similar. We start the worker thread. We explicitly start the worker thread. Whereas here, as soon as you leave this portion of the code, your worker thread is going to start. And then you use the join keyword to wait for the workers to be done. Now, I'm pretty sure there's a better way of doing this in Java, but this is what I can come up with. Any questions or comment? All right. Channels. So that feature, there's no channels in Java, so we're just going to talk about Go. I mean, I don't know. Maybe there's something similar. I don't know if it is what it's called, but channels. It's a conduit that allows you to safely share data. When I say safely, I mean concurrency safety. You don't without worrying about race conditions. So you can use channels to share data between multiple channels, between multiple Go routines. So I'm going to go over quickly what's going on here. So we have a worker function that we're going to pass in a channel where it's going to get work from. And when it's done with the work, it's going to use another channel where it's going to put its result. So we're going to look on the left side in a minute. So this, sorry, I clicked. So this portion of the code is looping and pulling values from the channel. The channels are typed. So here, what this is saying is I want to read or receive only channel, meaning I'm going to pull stuff from it of type string. So we can only put string values on that channel. So we're going to read from it. And once we get a value, we're going to do something with it. And when we're done, we're going to put the result in this send only channel. That's the syntax to indicate receive only channel, send only channel. And that's all you need to know. So that's what the worker is doing. Here, this is how we're gonna declare our channels. We call it jobs, and then we have results. And then here we're gonna launch our workers. And again, we're gonna use the Go routine to say launch all my workers. In this instance, we're just gonna do 3. And then once I launch my workers, I'm going to pass in the job channel and the result channel. So this will happen. This will not block. It'll happen and immediately return. And then once all my workers are done, when I come here and start putting jobs on there, it may block for a few seconds, or not a few seconds. It may block. It won't block because we're doing what we're declaring them as buffered channel. There's buffered and unbuffered channel. I'm not going to go into details what they are, but basically, as the name implies, if you have a buffer channel, you have a buffer basically of X number of data you can put in a channel before it blocks. So that's what these are. And then we put data in there and let that run. And then we come here because this is not blocking. So we just stuff data in there. We can come down here immediately and wait for the results and pop them out. I know it's a lot to explain. I put that on there knowing that it will require quite a bit of explanation for it to make sense. So if it didn't make sense, I'm open for questions. Otherwise, we're gonna move on because we're time is ticking. Any questions? All right. So error handling, I kind of mentioned that earlier. In Go, you are required to do explicit error handling. What does that mean? So let's look at this function here that returns a value and an error. So this right here, this syntax means it's because that Go can return multiple values, not just one. So in this, it can return from 0. I don't know what the limit is, but you can return 1, 2, 3, 4, 5 value. Usually it's just 2. But anyway, so this is also the kind of agreed upon way of returning errors. So you return the value that you're expecting and an error if there is any. So here we let's say if the content that we're receiving is empty, then we're going to return empty value for the string and an error to indicate that there was an error. So what we have to do is when we call parse content, we have to check to see if there is an error. Now, this is the one thing this is where a lot of people lose hope about Go and they give up. They're like, well, you mean to tell me I have to check everything every time, all the time? The answer is yes. You are required, you're not required, but you're expected to check erroneous values as you're making function and method calls. The reason why is that Go does not bubble up exceptions like Java does, for instance. So if you do not check your error, if you do not explicitly check your error, you run into the risk of if you don't check your error, you run into the risk of having silent errors just floating around and, and having code that is not correct. So that is why in pretty much all Go code, you will see something like this. You make a call to something, you check to see if there is error. You make a call to a function or a method, you check to see if there is an error. You don't have to return errors, but if you're not, if you want to indicate to your call, to your caller that there was an error in what you're expected to do, then that is the way that Go handles that. I know it's been described as verbose and primitives and all that stuff, but what it does do is make sure that you're confident that you are not leaving to chance that you'll have something going wrong at runtime because you didn't check an exceptional state in your code. Java, on the other hand, you sort of have, you optionally have to do it. You don't have to catch your exceptions because the runtime will eventually catch that exception and crash your program. Go doesn't have that. Unless actually that's a qualifier, doesn't have that. Go has a notion of something called panic, where you can tell the runtime that, hey, I don't care about anything else. Just go ahead and exit that program and crash it. And there's ways to gracefully recover from that, but that is something panic. You usually don't use panic. you usually use this approach to check every time you make a call, a function call or a method call, you check to make sure that there was nothing, nothing didn't go wrong with that. All right. Oh, actually, are there any questions? Comments? All right. The next thing is somebody asked about generics. I had mentioned before we started, so generics was implemented in Go very recently. Go is turning 16, I think this year. Yeah, I think this year. And the generic probably got implemented or got introduced in the last 3 to 4 years, no more than that. And before that, we did not have generic. And it was always a battle. Folks don't like Go because it doesn't have generic, and et cetera, et cetera. But I was one of those that was like, I don't think generic will add value. It's okay if we don't have it. But I will tell you today that now that we have generics in the language, it's one of my favorite features, because there's a whole class of problems that it makes Go that it wipes out. Take care of that for you. And the side by side here is showing you the difference in how Go does generic and how Java does generic. You can have type parameters on type declaration, as we're doing here, similar to in Java. You can have type parameters on classes, and then you can have type parameters on functions. So those are the two places you can have type parameters: functions or type themselves. The other thing I want to point out, so the other thing I wanted to point out is that you can put constraint on the type, and I'm not going to go into details how to do that, but in Java, you can provide bounds to the type parameter, and kind of box that parameter within a certain set of types. You can do something very similar in Go. Any questions? All right. Testing, that's another thing I wanted to point out. Go has built-in support for testing, meaning there are tools for testing built as part of the tool chain. And you can write what are called test functions, which is what this is. It's a test function. This one is a little complicated. It could have been simpler, but basically what this is doing is what is called a table-driven test, where you set up a different input values and different expected values, and then you set up a loop to go through each input values and test that. So that's what's going on here. Now, obviously, Java, I don't know if that has changed, but I know Java test support comes from third-party libraries, and that's how you do tests such as JUnit, etc. Questions? All right. So I'm either doing an excellent job or my internet connection dropped. Which one is it?
No, it didn't drop. We're here.
The first one.
Resource cleanup. Yeah, bar here. Resource cleanup. And that's very important. One way. So in Go, you have to do explicit resource cleanup, but you do it in a way where you basically use the defer keyword to say, hey, before you leave this block of code, this function, call this thing right here. and that's how Go support resource cleanup. So what will happen is this whole code will get executed, and you can have more code here, but before this, so this method will be called, or this function will be called come back, and then this function will exit, but right before it exits, it will execute your defer blocks, and you can have more than one to do, and that's where you would put your code that for cleanup or anything that you want to happen whenever before you leave the function. In Java, Java has more of an automatic approach to resource cleanup, where you use a try with resource, and it's something that allows you to automatically when the try succeed. Actually, I think whether it succeed or not, it'll try to do some cleanup afterward. Now, what I'm not sure is if you wanted to do is there a specific interface that you have to implement in Java to get your
Yes.
try resource to work properly.
Yes, there's an interface that has to be implemented to for the automatic.
Okay, that's what I figured. Okay, cool. So yeah, those are the two side by side for that. Here, there's no necessarily, you don't have to implement anything fancy. You just have to give defer an executable code block. It could be, you could define it, put the code block literal right here, or point to an existing name function, and it'll call that function for you, or that method, before it exits the function. All right, dependency management. We kind of saw some of that earlier when we were talking about, when we were looking at the code. In Go, when you put an import statement, or you put an import your import path for a package, that is information for the Go tooling. So what you could do is you could say, hey, go get that particular thing, that package for me, or you could do go mod tidy, and it'll walk your source code and fill in all of that dependency information for you. That's, I think I had mentioned that you can write it manually, but you don't have to. The tooling will take care of writing down what your dependencies are, so that whenever you're building or rebuilding or recreating your code, it can do a faithful job of reproducing the code as is written, as is recorded here. Now, obviously in Java, it's a more, I don't know if that has changed. It might have, but last time when I was using Maven, I had to, type I had to put in manually the jars and that make up my my dependencies. Like I said, I don't know if that changed where it's more automatic, but to my knowledge, it is still something that you have to manually do using Maven or Grade. Any comment on that?
Yeah, it's still the same. You use the coding tools now to automatically modify it now.
Okay.
The AI stuff can update stuff for you, or
Yeah.
but it still has to be created. Yeah.
Got it. Yeah, so this has to be created. But the Go module, mod is module, tidy is like the power tool that makes sure that all your dependencies are resolved properly and stuff like that. All right, so that is the end of the side by side. Like I said, I could have kept going, but I know, there's only so much we can cover. if you guys are okay, I can keep going and look at some more code. If not, we can, we can put a halt here and just do the question and answer. So let me know what you want to do. You guys want to look
I think we can proceed.
Okay.
Cover as much as we can.
Okay. Well, I got some more code we can look at. All right, so let's close this. Let's close this. So let's look at this code. So you can see some of the this is so I had mentioned a type called slice. So this is a two-dimensional slice. Again, a slice is like an array, but it's dynamic. It's in size, so it can grow and shrink. So I'm doing this is a slice literal where it's a two-dimensional where we have inside one dimension is another slice. So that's what we're seeing here. And there's nothing particular about this piece of code. The one thing I would point out is this package. This is the package that you would use to output to pretty much anywhere, including the console, including anything that will take a stream of bytes. And here I'm using it to output to the console, and this is what this stands for. It's pronounced FEMT for format, and it has a bunch of functions in there for formatted output in Go. So this is what I'm doing here. It's a formatted output. There's yes, Java has its own formatted output functions. I think it's in the system.out package, something like that, where you can use that to output formatted strings. And what does that do? It's my place. All right, sorry. There you go. IP3, no 4. Hello world. All right, so if I run that, let's move this to the side. We'll run that. Oh, okay. All right. Okay. So this is a good error because I'm going to show what I had mentioned about when you start a brand new pack. When you start a new project, you need to initialize it. So this particular directory is not part of any module. So that's what this error is saying. Hey, I'm not part of a module, and you need to create a module. And so that's what I'm going to do. I'll do it in here. And so, wait, what's going on? Okay, so if you look, you will see that now I have a Go mod file. If we cat that, it's blank because that code is not pulling in, doesn't have dependencies or anything else. Now, if I try to go run dot, it should run. Okay, so now that the tooling recognizes my source code as part of a valid module, then it went ahead and compile it and ran it for me and output the and show me the output. All right, let's look at something else. I know you guys probably want to know how to write an HTTP server in Go. I'm pretty sure you're dying to know. So here's a simple HTTP server. So one thing I want to point out is that this code by default is performant, meaning that I can take that and wrap it in, in a container or put it behind somewhere where it can be exposed to the outside world, and it will work. It needs nothing else and the reason why it doesn't need anything else is because the built-in network and HTTP package that are in Go are written to be out of the box performant. You don't need anything else. You don't need any additional tools, or when I was doing Java, you needed a web server or something separate to host your code and run it. So you don't. And that plays well in the single binary mantra that we talked about for Go, is that because Go, the standard library has everything you need. When you build your program, you end up with a single binary that has everything you need. So if I come here, let me come in. Actually, let's go over this code real quick. I'll start from the bottom. So this is my main, meaning that this is my entry point for my executable. We're gonna print some stuff, and I'm gonna use the HTTP package, which is here, right here, and I'm going to specify a handler function that will handle requests that come on this path, right? So whenever I see that, I'm gonna basically hand over the request to this function right here, which is defined here. And that's it. So this function basically will receive the HTTP request. And then what we'll do is, what this particular function does is it basically returns the current time as a JSON formatted blob, basically. And that's what, so this is doing this is basically formatting specifying what time format to use, which are these. So you have time 12, time 24, date short, date time 12, date time 24. So those are stored in a map, and when I pass the name, the format that I want, I get back the format, and then I use that to return the format that I'm looking for. And that's it. So this, like I said, is a valid web server. It's both it's your program and a web server rolled up in one. So let's go ahead and run that. This is in EP9. Service 2. Okay. So, all right. So I'm gonna go and I'll just do a go run on it. Okay, so as expected, you see that it printed where is it? It printed that starting the server on port 8080. Now, because I'm running in the cloud in CodeSpace, I just got a pop-up that says, hey, we just map port 8080 for that process that you just started. So you can access it in the cloud. So let's see if it'll open it. Yep. it opened a new tab. Now it says 404 page not found is because this default request is for it's for the slash path, which I don't have a handler for. The only handler I have is for slash time, right? So when I did that, it returned the I think it's UTC time. So if I wanted to, we could do something real quick. This. I'm going to add a another handler. We'll call this slash. I don't know. And we'll just return. All right, and then we'll all right. So now if I restart, now if I go to now when I land on the slash, now I see the default handler or the slash handler being invoked. And if I go to slash time, we should get our time back. So again, it looks like a simple piece of code, but this is pretty much what you do in Go to create massively scalable, web services, basically. I mean, it has all the ingredients. It's not a true web service because there's a lot of things that are not being done, but the essence of it is I could put this out and it'll scale for me automatically as more and more people hit it. There's nothing else for me to do. Any questions?
We have some questions here from Pierre. Pierre, sorry, I know I didn't see your questions on the chat. And so we have two questions from Pierre. Is saying about in your experience, if the same Java application were developed in Go, would the memory and CPU consumption be better in Go, where there's a high concurrency? And then, of course, I think we all know the answer to that one. Yeah, big difference. I'm sure you can explain.
Yeah.
And is there tools like JVisual VM to see the internals of Go? So those are the two questions.
So the last question, are there tools it sounds like to disassemble
internal state. Internal state. That's the virtual VM gives you a kind of snapshot inside the JVM to see what's going on.
So you will not be able to see directly, but there are things you can do, there are tools you can do, you can use things you can do. You can pump out metrics. That'll give you visibility into your running process. You can run, if you have an issue, you can run your process profiled, and those are tools that comes with Go that will let you run a profiler on your code to collect metrics, runtime metrics that you can look at later. But the most popular things that folks do is use something like open telemetry, and you pump data into a open telemetry collector, or something like Grafana that gives you visibility into the process, your process as it's running. and there might be others I'm not thinking about right now. The first question was the consumption of the memory consumption and performance of Go versus Java. Yes, the binaries will be smaller in Go, and the start time will be much faster because keep in mind that what you're looking at is a single binary that has everything it needs, so it doesn't have to load a JVM first and then load your classes. But I do know that work is being done for things like Graal, and I think there's something else. Graal is the one I'm thinking of. I may be thinking about it in the wrong context, but I think Graal.
Graal has a feature which is a snapshot for
Okay.
quick. Yeah. So you use that
Yeah.
along.
I thought there's another project. I don't know if it's Graal, if it's something else.
It's in combination with Graal. It's called Crack.
Isn't there something where you can create a single binary that has everything you need?
The Graal VM generates a binary, a native
Okay.
binary.
All right.
And then the Crack feature is the one that generates an in-memory snapshot for
Okay.
even quicker loading than just the binary.
Yeah. Okay.
Because the binary still has a JVM. It still has, it's quicker, but if you want even quicker than that, then you need the Graal with the snapshot.
Right. Okay. Yeah. So, again, what I tell people is, the best tool for what you're doing is the tool that works. So Java's been around forever. It's probably going to be around for much longer. It has a, rich history, great tools, et cetera, et cetera. So if size, as far as, execution, the size of your binary is not an issue, then you're doing fine. But if it is an issue and you're looking for something that works, then, Go would be something you would consider. Especially in places where startup time is of the essence. Startup time is of the essence. And the fact that you have a single binary, I keep going back to single binaries because it makes a world of difference when, everything you need is in a single binary. You don't have anything else to resolve, and you just give somebody a single binary, and it makes you think about solving compute problems differently because you've removed a hurdle, which usually is at runtime. If you use Python, if you use any one of those what was the other one, Python and Node, etc., where you have to resolve a bunch of dependencies before you can run code. Things can go wrong at runtime when you're trying to resolve these things. Whereas when you have a single binary, you have a single binary, and that's all you need. So it makes a difference, makes the world different. But again, it all depends on what you're trying to do and what makes sense at that time. So I hope I answered that question. Any more questions?
Yeah, we have a hand up with Damien.
Oh, well, but it's a small one, I think, and then you just kind of answered it, Vladimir. Okay, I have what you have on your screen. It's in GitHub. You've shared it with me, and I'm like, I'd love to run it.
Mm-hmm.
You know what I mean? I clone it. Now it's sitting on my computer. I have Golang installed. If I type in Go version, you know what I mean? If I type in Go in my command line, it's working. So, and it's the latest version of Go, let's just say. What do I, if I want to run this program right here and do the Go space run space period, do the dependencies download when I do that? Do I have to run something to download the dependencies so that, any libraries that you use here, like your HPs, to be downloaded?
So the first one,
Yeah.
the tooling, Go tools take care of that for you. So
Okay.
when I don't have one that has a lot of dependencies, I would show you. I think I had
Well, this one has to have HTTP, right? The web servers.
Oh, but this is all. This is so.
That's all
There's
built in.
It's all built in. This is
Okay.
part of the standard library. Everything you see here is part of the standard library. That's why if I look at the Go mod is empty because you get that.
Right.
Right.
Okay.
But if I was to introduce dependency on something else, then when I do the compilation or I try to do a Go run, the tool will try to resolve that for me automatically because it knows what my dependencies are because of that Go mod. So when you deploy, let's say you create a library in Go, one of the things that you have to also put out there is your module file so that the tool know what you depend on. And when it pulls you, it knows, oh, okay, you depend on all this, so I'll just go ahead and resolve that. So it kind of cascade as you pull more things in, it knows what to pull, et cetera, et cetera, et cetera. But that happens automatically. You don't need to do anything else other than pull that library or that program and then try to run it and see what happens. Did that answer your question?
It definitely answers my question.
All right.
I have one more. It's a small one. Anything we should know about the version? Like, if I talk about Python, there is the old 3.0 and 2.0 debate, and what version is the latest fine? Have you found projects that are like, oh, I got to use the old version of Go because the latest version of Go,
No, so
anything like that?
No, nothing like that. So I made that comment earlier, I think prior to us starting. One of the big thing that the Go creators and in Google and the community, one of the big thing that is key as part of the Go mantra is backward compatibility, meaning that before they ship the next version of Go, they make sure that code as far back as 10 years ago, I said Go was 16. I'm pretty sure Go code written 10, code written today, if you're not taking advantage of any later features, should run, and vice versa. Code written 15, 16 years ago will run today. So there's something called a 1.0 guarantee, meaning that once the 1.0 Go went out the door, there's a large oversized interest in the Go community to make sure that anything that comes after that is backward compatible to that 1.0 guarantee. So much so that when a new version of Go comes out, you should be able to pull that and run it and not even thinking about it. So usually what you'll see is shops peg their CI/CD to the latest version of Go. Now, obviously, if you're going to take advantage of a new feature, then you might have more consternation about what that new feature mean, what it might break. If if it introduces anything that you may or may not be using properly. But the current code that you have today should be able to run on that new Go release at any time. That makes sense?
It does. Thank you.
Awesome.
A caveat on that, what happens is in the Java world, Java is backward compatible to like 1.2. What happens is the language itself and the runtime is not the problem. Most of 99% of the time, it's the third-party frameworks that are created that are the ones that break.
Right.
So like I have JDK like 1.6 or 1.4 in my machine. It has no problem running it with all the way to 24. The actual binary compatibility has always been excellent in Java. but that doesn't necessarily, what's happening with Go is that source code. So if the source code is not compatible because that library doesn't have a version, that's where you run the problems into. And Go is not that old to have these problems yet.
Yes. Go is, like I said, it's 16, and Java, I think you mentioned Java was 30. So, there's like a big 16-year difference. Yeah, so it remains to be seen what sort of issues that you will see. Now, one thing I would say, the other thing that helps Go out is the fact that the standard library is very complete. So before you reach, I should say, you will get a lot of mileage out of the standard library before you need to go and bring something in. Now, obviously, if you creating something of consequence, you always going to have dependencies on a lot of things. But, for the smaller, for the smaller project, you can get very far with just what comes with just what comes out of the box with Go. But yeah. Let's see, one more, and probably we'll call it quit. Because what time we usually stop? Is it now?
Oh, yeah, typically around this time, but we can run a little late.
Okay.
I'm good.
We stop, Vladimir, when it gets boring. It hasn't gotten boring yet. So keep going. Keep going.
All right. Good to hear. All right. So I wanted to show the versatility of the HTTP package. So the previous version, or the previous example, we saw how to write a server. This is how to use HTTP package to create basically to create a client, an HTTP client. Close this. Excuse me. So this is a simple HTTP client. It points to a URL, pull the content, and that content is now ready to be consumed. And that's basically it. And again, I'm not showing anything, anything complicated, but it can get much complex than this, especially if you're doing things like TLS setup and stuff like that. But this is a valid HTTP client, and it works. And if I run it, it'll pull the Wikipedia content and display it on the screen. Let me see. Yeah. So this one. Okay. So Go has a templating package built in, for lack of a better term. So it supports templating. And one of the things you can do with that templating package is use it to build web page. Back in the day, I remember using what was it called? Servlet. Is it Servlet? I think it was called Servlet. Where you would JSPs, that's what it was called, JSP. In Java, where you would use a templating language to display data that comes from that come from your servlet, and you inject that data into your HTML. So this is something very similar. Instead, instead of HTML, you get instead of servlet, you get a regular program that happens to start an HTTP server that can receive data, and then you can display it on a web page. So this is the program, and this is the handler. Same thing we did earlier. This is a HTTP handler, and what it does here is we have a type. We have a struct, as we saw earlier. So this is creating a struct, and we're putting data in that struct. We're putting the message, the field message is awesome, and the field time has the current time. So that's the data. Now we're going to use the templating engine in Go to inject that data that we just created here into the HTML. So we use the templating engine to parse this HTML that we saw here, and then we are going to execute it. So execute is when we inject the data that is in this particular struct. And if I run this, I should see an HTML page with a message. Now, this is what it looks like with the error handling in Go. So you see there's a lot of noise, not a lot, but there's a substantial amount of noise that is just to check for error. So here I initialize the templating engine by parsing this file. I could ignore this, but I better not. So I have to check it. If there's an error, I return an internal status error here. Here I make another call. I'm executing or injecting the data into the HTML. It returns an error. I probably should check it and make sure that nothing went wrong, so that I can make sure that the state of the program is correct. And the rest of this is pretty much what we did earlier. We put a handler on this path called hello, and when we hit that path, it'll call this method, that's this method we just went through. This is it has a little bit more setup because I'm instead of just launching the process, the HTTP process, I'm configuring it by giving it more settings, such as timeout, write timeout, and there's a whole list of server configuration settings you can set up before you start the server. So once I have the server all configured, I come here and say listen and serve. So it's going to use that data to listen and serve that is the server itself. That is what is gonna handle any incoming HTTP request. So let's run this to see what it looks like. This is in EP9 template 1. All right, so if I do go run dot, all right, I got to do the same thing again. I didn't initialize it as a module, mod init. And again, the module path prefix is completely arbitrary in this context, because I'm not going to publish my code. I'm not going to publish it as a library or anything like that. So it's not going to be reused by anybody else. So because of that, the path prefix is it's arbitrary. All right, so it's created. Let's go ahead and run. All right, I'm not outputting anything. So there you go. Let's open in browser. Okay, again, 404 because I don't have a slash handler, but I do have a slash hello. There you go. So this is hitting the server, and the server is forwarding the request to that particular to the handler that we just looked at. And again, this is this is, for lack of a better term, if this is all I was gonna do, it's ready to be, to go in production. But there's nothing else for me to do for if this was the application. And that's what I wanted to drive home. But obviously, I'm pretty sure, if you get a 500,000 visitor, you probably will want to, all at once, you probably would want to make some other adjustment to be able to scale better. But for the typical average use, this is more than enough. All right. I don't think I have anything else unless you guys have any question. I mean, I do have a whole bunch to look at, but I thought these were like the more interesting things to look at. Yeah, so if you have, if you don't have any question, that is as they say, the end.